We're super excited to have you guys here. We have 2 talks that are going to happen tonight. But before we get started, just a couple call outs so you guys know what the rest of the evening will look like. In case you need the restroom, it's right out towards the front door on your left, both for men and women. We also are filming tonight and we'll be taking pictures. If at any point you're uncomfortable with that, please do let us know. We'll make sure that we'll remove anything that you're in. Let somebody either in an Atlassian sweatshirt or branded shirt know if that's an issue. Also, Kim, who's right here, let him know, as well as there's another recruiter who was helping open the door. His name is Linus. Either one of them are here to be advocates for you also in case you are looking for a job. So we are very much actively hiring. Please let us know. We're more than excited to have you guys here and to talk to you. Anything else? After the talks, we do have alcoholic beverages and other beverages that will be out the door on your right in the Atlas bar. So please stick around and hang out with us afterwards. Otherwise, I'm going to let you guys get started.
Thank you, Shana. So, hi everyone. Thanks for coming over to the office. I'm Behrooz. I'm a member of Jira Cloud and a sub-team which we focus on performance of Jira on the cloud. So tonight I'm just going to pick at a few stories around how we try to tackle our performance challenges and trying to actually make Jira better, especially after a few years ago migration to AWS. So let's start with a very classic deployment model that I'm sure it's kind of basic for you. So we use EC2 instance, and we actually deploy a Tomcat on a Docker inside an EC2 instance. And we also use a very familiar pattern of sidecars, and for example, we use a Docker container, which is mostly for monitoring. And we also have another one for security. We also have a bunch of others which are not really relevant in the context of this talk. So, very basic model, very common model, EC2 instance, containerization. One of them is your main functionality and a bunch of others that actually help run the service. So, and again, if you want to zoom out on this model, we have availability zones. We actually have also an abstraction which is a bit different from availability zone, but again, not very relevant in this talk. We have a bunch of EC2s. We also use a database, RDS, other types, doesn't matter. So we have a VPC, we have an ELB in front, and again, we also have something which we call Global Edge, which is specific for Atlassian because we actually have a very global distributed customer base, so we actually need to have point of presence in different parts of the world so that every request into a product of Atlassian comes through one of our edge servers. So again, nothing really fancy or complicated. It's a very common model of deployment. But there are interesting things. So let me get started on some numbers. So we have about 200 EC2 instances. Again, for example, if you compare it to maybe Netflix, it's really much lower. So it shouldn't be that difficult, right? By the math, it's about 800 Docker containers. And again, if I just want to look at each container containing really one process, it would be around 2,000 processes at any given time in any part in or time zone in the world. The interesting thing that starts to change the story is that we have about 130,000 customers with different profiles. They are a spectrum. We have customers with 5 users. We have customers with 5,000 users on the cloud. The server is not in this talk, which means that we are processing about 1 million requests per minute for Jira. it can be said that it's a noticeable number, and it actually gives rise to interesting challenges when you look at the distribution of our deployment. So this 200 EC2 instances are kind of equally distributed in different regions of AWS around the globe. And we also have network, and just keep in mind that we're also using Linux, which I don't think is really the surprising part. The network is just a blurry thing, because if you guys have experience with AWS, there are certain things that you never can control in an AWS deployment. One of which is the network visibility. What happens to your request inside the network of AWS? That's why I just mentioned it here, because sometimes we can just say that it was network, but we cannot say more. But let's go ahead with this. What I want to say is start with a story. Let's say call it this episode 1. SRE get pinged. And this is a real, actually, Datadog diagram that I just pulled out for this talk, which just happened also about a few hours ago, but in a similar scenario. Not exactly this one, but very similar. So this says response duration. And as you can see, I have a red dotted line at the bottom, which shows our usual expected acceptable response time for the Tomcat run that runs Jira, which is by far maximum 3 seconds for the backend to complete a response. And then in the course of few minutes, we see that this response time just goes up and it goes beyond 30 seconds. And this is the first alert that SRE usually receives. But now the story is, the next question is that if you are a performance engineer, what would be your first place to look at? Where do we want to go from here? I mean, it's not only monitoring. We need to understand when we get things like that, when we actually receive regressions that are so high in a short amount of time, how do we react to such performance regressions? Where would you start in this diagram? Where would you look at? Any guesses? Okay. Storage? That's a fair guess, I agree. In the sense that what happens to storage? Yeah, bottleneck, like it's out, or for example, it's running a very complicated query that blocks for other requests. I agree. But another choice is also possible, and for us it's usually to look at the application itself. So something is wrong with the application, definitely, because this is the response time that we're getting from the application. So what would be the best candidate in this area? Tomcat itself, right? What would be the first candidate for Tomcat to look at when you have a performance regression like that? For example, one of the things that we look at is how many busy threads are we seeing from Tomcat based on our monitoring systems. So in this step, which is part of the analysis that we are going through together, for example, we see that our usual busy Tomcat thread count is about 30. Where does 30 comes from? Doesn't matter. It's by experience and how we have deployed Jira on AWS, and that's how the amount have actually somehow converged to this stable number. The important part here is that this diagram matches our previous one, which is suddenly we see a high increase of busy threads in Tomcat, which seems to correlate with the response duration that we also saw a spike in. So, interesting, right? So, this was episode 2, but then, okay, what's happening? What's going on inside these threads? What should I look for in the next step? Any guess?
Did anyone roll out at 6 p.m.?
Very good point. I will come back to it. Yes, could be. So which brings you to a very interesting area. How do you correlate your monitoring system with your change delivery system, right? A change delivery is a commit. It could be a deployment. Whatever your unit of deployment is, it definitely needs to have a correlation with your monitoring system, because indeed, one of the places that we look at such incidents is that what were the changes that we had in this, for example, if a Jira deployment takes 1 hour, when was the last deployment before this regression? And what comments or what changes actually made it through the environment on that deployment? Yeah, but let's say that in this incident we ruled this out. So a deployment was clean and we didn't actually find any regressions. We want to look inside, right? We want to look at this EC2 instance in real time with more precision. And now the focus is that I want to see what is happening in these Tomcat threads. One of the things that we have been heavily investing in, and we haven't yet really made it so far and still in progress, and that's why we are also sharing in this talk, is we're trying to leverage what is generally known as the Linux perf ecosystem. Linux comes with an interesting tool which is called perf, which allows you to actually look into different processes and understand what's happening in terms of instruction and runtime throughout the life cycle of your process. Specifically, Netflix is also a pioneer in this space, and you might have heard of what is usually called as flame graphs, so that you could actually use Linux perf to generate these events and then try to visualize them in a specific way. So let me clarify a bit further. So this is a small portion of a flame graph that is taken for Jira at the time of this incident. I might have made a mistake to miss an introduction to the flame graph here, but bear with me. So what happens with that flame graph is that you look at JVM and you see what Java methods are being executed at a given time. And then you make statistics out of it. And then one way to visualize it is to try to see which method invocation was happening more at that period of time, which allows you to correlate that statistics with the width of these boxes. I said a small portion because when I zoom in, it looks like more like this. So here I'm seeing that what's happening is that there is some, unfortunately there was no better way to increase the readability of this, so I'm just saying it loud. So every green bar is a stack element in your thread. And then what's happening is that I see that I have Atlassian Jira Search Provider, which is a class. And then based on the statistics, it's taking the whole area, which means that it's the base of many stack trace elements in that thread. And then whenever you go up, it means that you change your stack to a new method, another method invocation. And the width of the bar is basically the number of times that method invocation was observed by Linux perf in your running container. In this case, what we are looking, let me go back, is that, so if you zoom out, try to zoom out, this is the number of threads, that 300, you remember? We had a spike. So it means that we were having 300 threads at the Tomcat trying to do something which was not successful. We want to understand what are they trying to do and they fail. So one way is to look at it in the big picture, which is really not understandable. But the interesting part starts from the time that you know that there are some critical parts, as our friend mentioned. For example, database. So I try to search. I know that my package name for database in our code base is .star conpool.star. There are some classes that provide us with data access API, and they have this string regular expression in their package names. What happens in this analysis is that, so this picture is cropped, but in all threads, when you zoom out, you will be able to see that the top of stack is busy with a class with this package expression. Which means that all the threads in JVM are trying to do with something with the database, and they are kind of either waiting, blocked, or somehow like that. And the flame graph visualization is an SVG, and each bar is clickable. So this is the clicked version of the previous graph. When I click on it, then I can see more information and the analysis that I just told you. That at the top, so this is our, for example, our database connection pool provider, and at the top I can also see that there is a Postgre driver that is trying to do something. So I just told you about this in, I don't know, 10 minutes, 5 minutes, but an SRE, or a performance engineer, needs to do this in at most 5 minutes, because there could be at least 10,000 customers, or I don't know, whatever number, depending on the impact radius of such incidents that are being affected. And that's why we have tried to start to look at performance engineering in a difference with SRE. We are trying to look at processes, techniques, technologies that enables us to do better job at delivering an acceptable performance, either in form of perception of performance to the customer, or understanding or measuring what performance is, or trying to define better metrics in terms of clarity or simplicity or usability for SRE to be able to react to such incidents. So in this case, as you guessed, this was an RDS outage. I mean, yes, we could have also notified this by a different way, but there are many times that, for example, you want to find or use a Jira query language. If you are familiar, it's a very complicated language that you can actually filter out your issues on a Jira instance. And then, depending on the database size of the customer, it could actually be very time consuming, or there could be a bug in the part that either fetches the data set or parses the query for the customer. And that's why it becomes much more complicated, and we need to have better timings on understanding such areas. So after this, when the SRE look at what we call DB saturation, which is number of threads that trying to connect to the actual RDS instance, we also saw the same spike. And then when we look at, for example, CloudWatch or the RDS monitoring itself, it becomes available that, for example, one of our RDS instances were just having difficulty in terms of idle or network. And that's why we started to see and ramp up back all those effects for the Jira customers. So the story kind of ends here. I just want to put a bit of, so if I wanted to start with this, I think it became much more boring than the way I just said it. So hopefully this is now better. So why this is more, again, it's more important for us is that this is the context that we're trying to move based on. First of all, we are a very fast evolving company. So Jira has gone through a massive migration and refactoring in the past 5 years. And we are also continuing it with what we call generally as decomposition, meaning we're trying to extract a very fat web application as the old Jira Server product into a number of extracted services. But we're still in a hybrid mode, which makes it much more difficult, because when you are in a completely microservice architecture, dealing with performance and understanding your architecture is much easier than dealing with something that is partially a monolith and partially a set of microservices. The next thing which is very interesting as well is that performance is like the old-fashioned quality. So I, as a developer or engineer, just deliver the feature. I don't care. As long as I'm happy showing a demo to either my customer or my leadership team, I would be happy said, okay, this feature is done. But who can own the performance? It's really the engineer. And this is also a culture shift. It's like the DevOps or SRE culture shift that a lot of organizations have gone through. It's also, for us, one of the new elements that we're pushing for every development team to own. When you are working on a product piece, you are on a product team, you cannot say that performance is out of my context. SRE or performance engineering teams only show you the path. It's you as the owner of that feature that need to guarantee and provide. It's like the SLA, it's like the uptime. You have to own it. And it's also a culture work. It's not only technical. The other thing is that usually performance is a hard topic, because I just used a simple story. I'm sure almost all of you might have interesting other stories that couldn't be as simple to explain how you solve a performance issue, how you try to analyze what was wrong. And all of it becomes much more critical when a service is running and your customers are impacted. So that's why it's really important so that the concept of performance and the tools and techniques becomes easy and simple to use for everyone in your organization. So these are the things that we are trying to do better. So we use an RCA. What I just told was a typical RCA approach, root cause analysis. We try to look at what happened and we try to repeat a few questions until we reach the root cause. But what is important is that when you are in a large deployment, when you are in a large organization, it's easy to get disturbed or distracted by noise. We need to learn how to better focus on the relevant data, on the data that is really related to that part. The performance engineering, let's say that if you want to write a handbook for your team, it should be in a way that it could be adoptable by any team, by any engineer. There is no need to have really complicated concepts. If it's like that, it means that it cannot actually serve the purpose. And that's why we're also trying to make this a company-wide and easy-to-use way to own your performance on the product. One thing that is very important around performance engineering is that it's very easy to use what we call streetlight, or I think this word was first coined by Brandon Gregg from Netflix. It's just like try and error. You just look at something, if it doesn't answer your question, you just turn away and just try to use another thing. Performance engineering doesn't work that way. There is a very common technique and approach which is called USE, utilization, saturation, and error. It means that you actually have to form a basis. You try to need to collect proper metrics to be able to respond properly to your system. Which is to my next point is that you have to define clear metrics. You have to define metrics that are relevant to a performance. Any one of us can come up with a lot of metrics, but how they contribute, how they can compose to one another, to build a higher level metric. These are the things that are really important. And then of course tooling. So I think there are already quite a lot of tools around, especially around monitoring and observability. This is also a gap that we have identified. So a lot of times things like Datadog, Splunk, I don't know, SignalFX, tracing systems, these are monitoring tools, but they are not necessarily performance engineering tools. Based on the metrics that you define, you also need to understand what tools do you need. Just remember that 5 or half an hour incident. You need to be able to respond quickly. For that, we need tools. And that is something that you can define based on your own metrics. And then, of course, automation. And one of the main purpose of automation is to be proactive rather than reactive. So everything starts with an alert. But then what if I had this alert a bit more smart? And the rest of the story. But before all this proactiveness happens, we will also be able to remove human errors. I think we are all familiar with this topic, that human error in this area is sometimes very difficult to actually recover back. I'm running out of time, so maybe just to end. Again, if you ask me what is performance engineering, I really don't have a good answer. So, but these are the things that we have tried to orient our initiatives at Atlassian for the products that we have. We really think that it's a vertical process. It's something that you need to have a vertical understanding of your stack. You need to have a good logic around what your systems do. It definitely relies on observability, because those are the basic tools that you need to first have to be able to start to look at the concept of performance engineering. And then just try to make it a first-class citizen. Performance, I think it's a story that happens with quality as well. Performance is a cross-functional requirement, but it's usually not the first one. So just look at the products that have always been successful. It's almost definitive that they have performance from day one, and they never actually get rid of it. So hopefully this was just an introduction. We really hope to continue such meetups, and maybe in the next series of this area we could talk a bit about how we have tried to evolve Linux Perf as a service, so that you don't actually have to deal with a lot of challenges as an individual to be able to use it on a large deployment. And also, very much interesting area of front-end performance, because there was an implicit aspect of this talk that was everything was about a back-end performance. But at least for us, the performance of our products such as Jira starts from browser. How can we correlate our front-end performance to our back-end performance? How can we trace our requests from front-end to the back-end and the rest? So these are really the areas that we also very challenging, and we are trying to make advancements in this area, but not yet final, and hope to be able to share maybe in a later talk. I think I'm over time. This was an example. For example, this is a Chrome, and this is actually a Jira dogfooding instance. And FMP is the first meaningful paint. I don't know if someone is familiar with that. So one of the areas that is very challenging is that how can we correlate an FMP with the JVM's thread stack trace in the backend?
Well, it's the same.
Right. So it actually shows the same, right? These, I think Chrome calls it flame chart, and those are called frame graphs. But again, same concepts in different areas. How can we actually try to have them in a unified place? It's a very, very interesting area. Thank you very much for your time. I don't know if there's question. If we don't have time, I'm around after the second talk as well, so we can chat.
second. Let's I will that's what now I don't see anything here.
Okay.
Just gonna get water and we can get started. First of all, hello Meetup. How's it going? Hope you're enjoying the night. Thanks Atlassian for flying me here. Thanks everyone for joining. My name is Leandro, and I work as a research engineer at a nonprofit called Source. It's a pretty cool name. Used to work at Spotify and Klarna, so some of the things I say actually have come from very large production deployments, but at the non-for-profit, we're doing very different things. Source stands for Software Research Center. It's based in Stockholm, and we run completely in an open source fashion. You can find us in GitHub. We have a repo where we have everything that we do, like board meetings and stuff. Right now, we're doing a lot of work on the Reason and the OCaml ecosystems. We're working closely with the Reason Association, and we're trying to get some of the documentation story in place. You can find more about us here. So I'll do a small pause here. This is the title of the talk. Can you hear me well over there, all the way in the back? Can you see everything? Is it crisp, clear? Good. I'm going to take the idea that the prior speaker had about sharing stories, and I'm going to take it to the extreme. I'm actually going to be telling a single story. This whole presentation will be the story of a team led by an engineer, and essentially how they overcame a lot of problems as they started scaling their product and started scaling their team as well. There may be a few awkward pauses while I sip on water. Bear with me. All right. Say hello to Jane. Jane is the lead engineer in a team, right? She works at a company that is growing really, really fast. Fast-growing company. Did something happen with the volume? Okay. And her team is in charge of building tools, right? She builds with her team a lot of tools for humans. People actually use these tools. It's not all the machines. It could be tools like we saw before, build flame graphs, all sorts of tools really. For building things, for putting things together and taking them apart. They do some dog fooding as well. They measure things, they observe stuff. They have around 44 tools in over 1,000 different modules. These are mostly JavaScript modules that are spread over 78 different repositories. So there's a ton of stuff going on there, right? It's a pretty big code base. The team is just churning on, pushing code, and delivering as much value as they can. But it has some issues, right? One time they actually had about 4 different pull requests to get one bug fixed into production. And if you work with microservices and multiple repositories, you're probably familiar with this. Please wait on this PR and please also wait on that other PR before we actually release this thing into production. I'm hearing something with the microphone. It's sometimes it's really loud over here. Is that?
Let me have it.
I don't know. Okay, no worries. I'll continue. Sometimes it's even worse. This one time it actually took 9 different pull requests in a synchronized fashion to be able to make a delivery, right? They had one repo over here at the bottom with a very tiny module. They had a typo somewhere. They had to fix that, and they had to bump versions of another 5 different dependencies, and that in turn had 3 more dependencies on top. It was hell. The worst part is that they had false positives because the interfaces were dynamic. So when the tests were saying, yeah, this looks good, the moment they started bumping dependencies, right, some of the other things started to fail. That's hell. And no, if you've done microservices like that, this is not easier to debug. It would be easier if everything was in one place, right? Someone said, maybe, and I'm going to try introducing some team members. You might recognize them across the slides. Someone actually said, maybe we can try TypeScript. I've used some of it. It seems like a cool thing. It will remove some of the dynamic checking between dependencies while still allowing us to be fairly dynamic. And the reality is that it does help, and it helped just fine for a little while. There were a few issues, right? You have all these repositories, and some of them are starting to use this type definitions. So the lead engineer has to, put on her let's say, a policewoman had and say, well, we need to keep these things in sync. You made a change in this repo, right? So the interface changed, but this change is actually not backwards compatible. So we need to make an actual major dependency bump, which means we need to go around all the repos and make sure the caret that we're using to pull dependencies actually picks that up and so on, which is a royal pain in the ass. But it can be done. Another issue they had is that people write TypeScript in very interesting ways. It's a very, very complex type system. It's actually Turing complete. So you may build a program that never finishes type checking, which is kind of insane, but it's possible. So she had to, essentially, what do you call this? Get on her professor hat. That's not really a hat, but you get the point. And start teaching, okay, we should probably write TypeScript in this way and not in that other way and so on. But ultimately, they decided to go with a monorepo. They took all the projects they had. They spent about 3 weeks, which not every company can afford. But I hear a chuckle over there. And they moved to a monorepo. Now the overhead that they had is gone. At least that overhead. Now they don't have to keep versions in sync because there is no version, right? Everything is the hash that you have in Git or in your Git repo. So if you want to see what version you're running, just take a look at master and you'll see, oh, this is the SHA. So all of the versions in the interfaces across the libraries are using the same SHA. If you want to make a backwards incompatible change, you fork the library within the repo. Now you have to maintain twice. Now you really see why it's a bad idea. But anyways, things were good. Things actually got a little better. The team grew a little bit. There's some characters in there as well. We got a scientist, a data scientist. We have another good engineer, and then we have a front-ender that's a little more on the design side of things, more of an artist. The repo actually started growing as well, right? And before we knew it, it was massive. So this team started with this very distributed set of projects, and they sort of joined all of it in one place, and they started growing that very slowly until it became pretty big. At that point, Jane noticed something, right? She's always keeping her eye open into what is going on with the team, how they're reacting to the code, how is the code evolving with the team, are we learning the right things? She saw that the test and the type coverage are actually improving, right? We have more tests now that everything is in one place. We have better type coverage. We can catch bugs faster. But there was another thing that was going up, and it was the build time. Right? Before, everything built very quickly and very fast and very separately and very eventually consistently. And now everything builds at once, but you have to build everything. There's tools for fixing that, right? But she started to wonder, now that we have this single source of metrics, this one repository essentially told us this about it. It's a measurement of health. Can we try to come up with a measurement of quality and measure the health of the code base against that quality? So after some back and forth with the team, they decided that the total bug reports was going to be what they cared about. Again, they made up this measurement of quality, which can be different for your teams and your products. You may actually not have a lot of bug reports at all for it to be meaningful, but since you're building tools that are internal, this made sense. A lot of people are complaining on Slack, hey, this is broken, or I can't use your library. So they kept track of that, and eventually they put up this chart where they show, oh, all these things are going up, but the price we're paying is not actually worth it. We thought it was a really good idea, but now we're realizing that maybe we just spent all this money, all this time, right, in vain, which is terrible. Oh, yeah, I had another slide, but I gray out the other two, so it's clearer. That is the total bug reports going up as well, which is unexpected, but it still happened. Some of the reasons that they found out, and that's not a pun, is that the way they were writing type definitions was a little too powerful sometimes, and not all the tests were actually catching the different combinations of libraries they were using. So the iteration cost is going up and up, right? Every week, everything gets slower. You make a pull request, and it takes twice, 3 times as long. But the quality is going down. So the researcher, right, the data scientist says, well, I like to write more tests for these core modules, but things are getting slow. And the TypeScript advocate says, well, if we just add TypeScript on those modules, then TypeScript will help us refactor them, it will be safe. And then the designer, which has a different, let's say, sense or sensibility for complexity, actually jumps in saying that this is just too complex to touch, I don't want to deal with that, just give me the library that does the business logic, I'll just do the components on top. So Jane thought that maybe we can make an experiment, right? If we set up some premise, maybe we can do something and see what the outcome is. Not too different from what we just saw on screen. Of course, the data engineer, the data scientist is excited about this. So they decide to take a piece of the core library and rewrite it, right? But they want to consider a particular criteria. They don't want to just redo the same thing using the same tools to measure maybe how good they have become in that language or in that platform. They want to have very, very clear goals and metrics for what is it that they're trying to measure with this particular experiment. Some of those metrics are here. I'm going to take a second to try to go through them. They want something, right, that integrates with their existing mono repositories. They don't want to jump in with a tool that will force them to break out of the patterns they already invested in. They want to avoid unnecessary complexity, and that's really hard. Most of the languages that we have are Turing complete, so you can do whatever the hell you want. They want to have build times of under a minute, and this is arbitrary, but they set it to be able to measure, well, we hit this goal by 90%, or we fail by 45%, and so on. Same thing with the tests. They want to be able to run the tests in under a minute. Whatever solution they go for, it has to have a good community and has to have good documentation. It has to be something that they can rely upon. And it should not introduce any performance regressions on the actual tools. So what could fill these requirements? Anybody? Any thoughts? Any ideas? I see someone very excited over there, but I don't know if you want to say something.
You pull the base module at the runtime. You separate out the base module, and then you pull it at the runtime so that only what is required is tested, and so the testing time comes down.
So then you would only test what's required.
So it's like.
Do you have any guarantee that only that piece of code will be included in the application when it runs?
No, but if those are the only modules being pulled, then they must be tested anyways, right?
Yeah.
Yeah.
Well, that's one alternative. Anyone else? Anyways, I'll continue. Obviously, the TypeScript advocate just jumps ahead and says, I would like us to use more TypeScript, right? We're using some of it, we want some more. But the data one is thinking, maybe we could try Reason. Maybe we could actually give this a shot. I've been playing around with it, and this is half sales pitch from her, but also her experience applied to building things with a tool maybe helps. I think most of us have been in teams where someone has introduced a technology because they were familiar with it already, and that's sort of how these things get in. So they began the experiment, they began going through the goals and metrics and trying to figure out how they can use this with the current requirements. The first one is, it has to integrate with our existing mono repository. So how do we integrate it into a repo, right? The reality is that you have a bunch of JavaScript, and some of it will run a node, and some of it's going to be bundled somehow and maybe get exported in different bundles or run elsewhere, right? You just need to figure out what is it that you want to replace first. So let's say we mark that one in the middle, right? And we do this, right? Almost. By using a compiler that can take this code back into JavaScript, right? This one in particular is called BibleScript. You can begin by picking a particular module in your core application and saying, this is core, this is very important, it has to be thoroughly tested, it has to be actually checked to the point of exhaustiveness. Let's write it in Reason and compile it back to JavaScript, preserving the interface that the rest of the modules used to talk to, but changing all the internals. And after that, if that works all right, then you can get the next one, and then you can get another one, and before you know it, most of your code base or the important bits can be written in a language like that. It's a sensible approach for migrating a project. I wouldn't suggest, and I think they did it for a reason, rewrite everything from scratch. That second system syndrome. Anyways, we can very gradually replace all the parts, right? However you feel see fit. And she seemed to like it. How can we avoid some of this unnecessary complexity? Right? Second goal over here. So Reason has a type system, right, that is actually very, very small. Compared to something like TypeScript, the Reason type system is printable in a shirt, right? You can have this one little thing here that says, oh, these are unions, these are variants, and so on and so forth, and it will fit in a shirt, and you can read it. It's not going to be something that you can use a microscope to read. So they started wondering, how do you actually do anything only with variants and records? And I'm being a little simplistic here. They have some other things, but those are the core elements of the type system. But people get stuff done. The reality is that most of the work that we're doing involves data that has in two different sort of natures. It's either an alternative of something, of a group of them. You have a set of elements and you pick one of them, right? Or you have a set of elements and they go together. Either you have a variant, one of these alternatives, or you have a record. All these things need to be packed, right? The variants you separate with an OR when you say, I am a speaker or an attendant or an organizer, right? The record is something that you join with an AND. I have a first name and a last name and an age, and so on. For example, here, the role of a user could be an admin or a moderator or a normal user, right? This is one of these things, or. Whereas on the other side, we have, I'm going to use this side, of course. The user is a username and the password and the role. And of course, if you do the math there, you'll see that for every user, right, you can have any kind of role. So you can say, you have 3 different roles, right? How many users that have the same username and password can you build? 3, right? You say 3 by 1. If you had another variant that had 2 options, right, whether the user is verified or not, then how many users can you build with the same username and password, but different roles and verification status? 6, right? By doing simple math, very simple math, 3 by 2, you can sort of see how many possibilities, how many elements this set, this space has. Of course, when you use something like string, then it blows up. You can put the complete works of Shakespeare in Korean, and that will be a valid username, assuming it doesn't, go out of it. But anyway, how well does this scale? And you may think that this is a simplistic approach that maybe comes from academia and just is not usable in real life. You need more complex things. You need these discriminated unions in TypeScript, or you need no types at all. You actually need flexibility. But the reality is there are people, right, that have built things like Mirage OS, a complete operating system built for networking platforms that run as a unikernel, right, only with records and variants. So because of the nature of the data that we work with is fundamentally either ands or ors, you can build as complex data as you need, right? And I had a very poor inflection in that sentence. You can build as complex data as you need. There. So the next thing that they looked into was the build time, to try to keep it under a minute. And that was because it was going over a minute, but I realized now that charts didn't have access, which was intentional. But comes a designer saying, holy shit, did you see this? There's some benchmark where you can build 10,000 modules in 3 minutes on commodity hardware. And that actually is not something I made up. It's a valid performance benchmark that the Backlscript people have built. You can run in your computers, and it's just ridiculously fast. I will actually run it if we had a little bit more time, but the reality is that Reason is not a language that's new. It's a language that's really, really old. It's about 25 years old and comes from OCaml. Reason is just a new syntax for a very old language that has tons of man hours invested from both the industry, in companies doing financial, quantitative trading in financial systems, and also academia, into making it not just robust, but also fast. Some of the things that you can do with OCaml as a compiler you can do with other compilers that have seen much more widespread usage. Try comparing Java C to OCaml C and do it on your own. Pick whatever test you want, and you'll just feel the difference. It's not just something that you can see, measure, it's something that you can feel. The next requirement they had, and personally this is the one I like best, is that they wanted to have tests that were being able to be run in under a minute. And sometimes that's insane. Sometimes you have batteries of thousands of tests, and you have to wait for them to coordinate services. But in this particular scenario, they aimed at the unit tests that they have, or the tests that coordinated libraries, not necessarily systems, right? So they were thinking, oh, well, the tests are still running slow even though we started using this language, right? What is it something that we can do? You may notice that because we were using Reason and compiling it to JavaScript, we're still running our tests through Node, right? You still go into a headless browser to run some of these things, for example. So the data scientist comes back and says, well, actually, there is something we could do. We could try to compile some of the tests to native code. And I see some of you shaking your head, but there's parts of your application that is really just business logic. It has no I/O whatsoever. You give it some inputs, right, that are already pieces of memory inside of, pieces of data inside of the memory of your program, right? And then it spits somewhere of the same thing. It doesn't have to talk to another library that maybe is implemented as FFIs. It doesn't have to do any of that. So if we spend the time compiling those things, maybe we can run them natively, and we can run a few thousand of those in a few seconds. There's a branch of the project called Reason Native, she spoke, where people have been actually trying to get the same UX, the same developer experience, the same familiarity in building tests in a TDD or BDD sort of way, but with the performance of native compilers and native programs. This is one very interesting example that I took from some of the internal libraries from the Reason Native, where you can see here, I don't know if you can see in the back, sorry about that, but it's running about 3,300 tests, right, in half a second. And when I saw that, I was first very, very, what do you call it, when you don't believe something? Skeptic, thank you. Skeptical about it. I said probably those tests are just opening up and doing nothing. When you try to run tests in this volume using something like Jest, for example, you have the overhead of nodes spinning up in a few threads, and that might be 300 milliseconds, which is already almost the same time this was taking. This has none of that overhead, right? So I started digging and I started running them myself and trying to break some of them, and then I realized, oh, this is actually testing things. There's tons of code in there. It's really fast. So I said, sorry, I'm getting ahead of myself here. It's like Jest, but with a node, so you could run all of your tests in a few seconds. That's a very broad statement, but plenty of the application that you're running, at least the parts that are just logic, you could run as fast as you want. Right? Don't quote me on that. 50% the speed of C. That's what OCaml claims. The next thing that we have, and I'm running out of time, so I'm going to speed up a little bit, is that we need a tool, we need a solution that has a good community and a good documentation set around it. Right now, the community has a very vibrant Discord channel with a few thousand people that are going in and out and talking every day on most time zones. So if you have a question, you can go in there, and some of us will help you out. We'll figure out what the problem is and just chime in. There's a forum as well, which is not as frequented. People are actually doing a lot of very, very short, fast iteration on everything because the feedback loop is so short. So you may see more long forum posts about the releases of libraries in the forums. There's also the official websites that explain what is the platform and why do you want to use it, right? So just making some compelling arguments here. It's not like Reason is something that you have to go read a bunch of source code to get started with. There are tools both in the compiler and the language level to get you started. There is a whole nonprofit, an actual association dedicated 100% to making sure the ecosystem is steered in the right direction by the community, for the community. They organized a conference that actually happened 11th of April this year. It was super cool. And there are initiatives such as getting the doc generation in place that are reusing very heavily parts of the OCaml ecosystem to make sure that all of those 25 years of development that they've invested, we don't waste. ODoc, one of the tools that they're trying to port, and I've been involved in this particular effort, has a way of building documentation for the whole ecosystem, not just for your library, to the point that they can detect a bad reference between libraries in the documentation. So you say, oh, you could look at this function that returns this data type that's in this other library, and when you try to compile it, it says, wait, that doesn't exist. So your docs can't point stuff that doesn't type check. Try doing that with JSON. And lastly, but not least, I think it's very, very important, one of the reasons I agreed to come here is that I really believe in meetups. And Reason has tons of them all over the world. They're sprouting like crazy. They're led by crazy people that want you to get excited about the language, that want you to start writing things. We organize dojos, we organize some events that are actually synchronized across the world. We did the first one, I think, last year, around this time. We actually got maybe 27 dojos across the world to at the same time get started on a project, and we worked together for like 4 or 5 hours building this application. It was really cool. So yeah, there's plenty of documentation, but how do I know that that's not just me writing those websites, putting screenshots up there? Who's actually using this? Who's actually investing in Reason? And the number of companies that are using Reason right now is growing very, very fast. You may be aware that Facebook is behind the Reason itself language, right? Not necessarily OCaml, but the language Reason. They rebuilt parts of Messenger.com, a big amount of it, with it. That's the Reason Association, which also have their own software projects. Amandra from AI, Verified AI. They're doing incredible things, trying to verify React applications, where you put it up to put your application up, and you say, "This is what my state looks like in terms of the data space." And then you write a query that says, "I need an application that has 4 to-dos. One of them is already checked as done, and the text is in Chinese." And they generate data for your test cases, and you can verify that. It's pretty interesting. I mean, I could go on for a long time here. RFs is a huge company built on OCaml, and they're starting to go crazy on Reason for all the front-end things. They essentially keep the internet archive. I think it's not archive.org, but they have their own archive. And there's also some books out there in case that the team needs some help with that. Exploring Reason ML and functional programming, one from the pragmatic programmer from David Eisenberg. He did some publications before as well. And then of course we have all of the documentation from the 25 years that OCaml has. All of it is 100% applicable to Reason. So that's roughly all the requirements that we have. The last one I'm just going to run through is that we have this server node that's going a little slow, and we don't really know what is going on. And then they ask, what is it that's slow? So, well, we added a new feature, and the feature is actually making, the 90% of the requests about 400 milliseconds slower. So they just wonder if we could run it natively. And the reality is that no, you can't if you want to stick to Node and your Node frameworks. But the moment that you are familiar with the syntax and the type system, yes, you can. You can start moving away from Node, and you can start moving into the OCaml ecosystem, right? Where you have libraries that are built for very, very high performance. So you remain with the same language that already made you productive. They have a type system that keeps you safe, that keeps you moving fast, but also you get all the performance of running natively. There's a package manager and an index of packages that has thousands of packages ready for you to write native applications in the same way that you just wrote a bunch of Node stuff. And there's also efforts trying to make the whole ecosystem of OCaml feel like you're just running Yarn. Yarn add this thing, Yarn run, and so on. And it works really, really well. So somewhere in their requirements, right? Long process, and they wanted to look what the metrics look like at the end. The results of the experiments looked a little bit like this, right? The type coverage was through the roof because you can't have stuff that's not type checked in Reason, right? You can't just say, hey, this is X. What is it? Is it a string, a number? I don't know. We'll run it and see what happens. The build times actually went down because the compiler is so damn fast, right? And they saw as well that the total bug reports was going down since they started the migration. Well done, team, right? We've successfully made our products better. The gist of the whole story, which I'm painfully aware it sounds like a marketing pitch, is that Reason helps you build great products with teams of any size, and it does it at blazing speed.